In this video, we will demystify the DevTools network tab, and we're going to understand all of this stuff, guys, including the protocol and all the other fields. If you're interested to know this and interested to improve your back end and also possibly your front end, stay tuned for this video. Let's just jump into it. Hey guys, what's going on? My name is Hussein and I discuss backend engineering on this channel. And some of you ask me, Hussein, can you demystify the DevTools tab? Because that tab is very, very critical for diagnosing your backend, actually. So what we're going to discuss here in this video is the network tab in DevTools, and you can access this network tab by going to these three dots in Chrome or Firefox. I believe you can do the same thing. More tools, and then you click on developer tools, and then click on the network tab. And in the network tab, we're going to explain all the fields in the network tab. And the first example that we're going to take is actually going to example.org, because that's the simplest site I could find to explain it. And then after that, we're going to go to a more complex site and explain more of the more complicated requests. How about we jump into it? So I'm going to example.com and I'm going to open the network tab and hit enter. And the moment you do that, you're going to get one row in this table. And this table says name. That's the name of the resource you request. Method, status, protocol, scheme, remote address, type, initiator, size, time, and connection ID. By the way, you can add more columns by right-clicking and just literally clicking there, right? And cookies, all that stuff. But I'm not really interested in the cookies per se, but all of this fields are really, really valuable. So how about we jump into it, guys? So what did we do here? We made a single request to example.com. The method, HTTP method, was get, and we talked about get and versus post. Check out the video right here if you want to learn more. Their status as a result coming back from the server says 200. That tells me that the request was successful. The protocol used to communicate with the backend is HTTP 1.1, and we talked about reversement to HTTP 1.1, HTTP 2, HTTP 1.0, HTTP 3. Check out the video right here to learn more about HTTP protocol. But that tells me that this is definitely a TCP connection. That also tells me that it is one of many connections, possibly, right? Because HTTP 2 we multiplex. However, in HTTP 1.1 we create multiple TCP connection and kind of send multiple requests in each TCP connection. Each request is sent on a single TCP connection at a given time. You can't send multiple requests in HTTP 1.1 on a given TCP connection for a given time. So the scheme is HTTP. That means this is unencrypted, and this is a good choice. I explicitly picked this site so it's unencrypted. Domain is very important here, so I added that. So we're going to domain or example.org, and I also added the remote address, so you give you the actual IP address plus the port, since it's unsecured. So port 80, and that's the actual IP address of this thing. Type is document. So I'm gonna hide the type because it's not really relevant to what I'm gonna explain. I don't care what's the type of this stuff. So I usually hide this. I usually also had the initiator. This is like front end things for people who actually in the front end want to know what made this request. This is a good field. But to me, I'm just measuring. I'm just checking the entire site, right? So I don't really care about that. Size is also good, like what came back. That's good. Time, how long it took. So 42 milliseconds. And connection ID. This is one of the most important one, in my opinion. Okay, the waterfall, which is the actual breakdown, I'm gonna make another video discussing the waterfall, just because I don't want to make this video very long, right? So this is all the fields. Okay, so this is not a fancy request. If you see what we did is like we made a GET request and we got back the response headers, and then that's it, which is the HTML page, right? That's the content. That is the response is just an HTML page. So how about we do a little bit more of more interesting requests. I'm gonna go to nginx.org. Let's clear this up. nginx.org is also by default doesn't have HSTS, which is the HTTP strict transport security. So it will not direct me to the HTTPS side, despite there is an HTTPS endpoint. But if I type it like that, it will prefer this unsecure side. So again, I'm not going to explain this in this video. I'm going to go through this. So what happened here? What do we see? We see a bunch of lots of requests. I want you to pay attention. So what happened here is the first request that we made was to nginx.org. And nginx.org returned a big HTML file. And the next step that the browser did, browser literally froze. Sheesh, seriously, browser? All right, guys, I had to execute this because the browser just froze. Well, it looks like we're doing so much. All right, so the first request we made was nginx.com, nginx.org, and get the HTML page. I'm not going to open it because this will freeze it again. But this is a get method, so this is just a safe, hey, give me what's going on. But I did an HTTP 1.1. The scheme is HTTP, it's not secure, right? So there is one TCP connection that we create in order to send that request. And here is the TCP connection, 44563. I absolutely love the fact that it is numbered, because you know which request belong to which TCP connection. And this is very critical for us, right? To know, to understand how many TCP connections are there. And then the next thing is like, okay, we have this, the Nginx, so this is the IP address, right? And let's pay attention to the IP address. And it better, if it's the same connection ID, it better be the same IP address. Otherwise, it doesn't make sense. So it took 162 milliseconds to just retrieve that HTML page, right? And then we followed it up with another request for some reason. What are we asking for? We're asking for the PNG, the first resource, which is an image, right? So we're asking for an image. This one of the page, this one of the image. And then follow using the same TCP connection. So this had to queue up in order to be sent in the same TCP connection, because you cannot use, I take that back. So the first request was sent on this TCP connection. Once we got the result back, we used the same TCP connection to send another request on the same TCP connection, HTTP 1.1 as well. So and then we followed up with a JavaScript file that was sent on a different TCP connection. Why? Because it's not in the same domain. This thing, guys, we're going to Google tagmanager.com. So here's what happened. My assumption is Nginx is trying to track us through Google and Facebook. We're gonna see Facebook in a while here. We're gonna actually see Facebook because they are tracking you, so they can sell you their ebooks and stuff like that, right? Through Nginx ads, through Facebook ads and Google ads, right? That's just the tracking mechanism. And to do that, what they do is in the HTML file, they make a request to Google Tag Manager or Google Analytics or all that stuff, right? When you do that, by default, the first attempt was an unsecure HTTP request, right? And that returns 307. What's the 307? Let's check. 307 HTTP code. What was that? I forgot. Temporary redirect. So that means, hey, redirect. Where are we taking me? What are you taking me? Go to the secure site. So for some reason, Nginx, the HTML, had HTTP access to that link, right? But that site, so what do? We established a TCP connection, right, to this site. We sent a request and we were told to go somewhere else. So we closed that TCP connection apparently. And then we established a brand new one using H3, which is HTTP 3 Q050. This is a specific quick version. And I'm going to make a video talking about quick, which is the HTTP 3 protocol, specifically just for Chrome. Chrome's implementation of quick. And this is the denotation Q050. If you see H3-29, that's the official IETF HTTP3. Okay, so we're establishing it because we're in Chrome. We're going to use Chrome to do that, right? If you're on Firefox, you're going to see, I believe you're going to see the same value. I might be wrong there. All right, so we sent that information to the server, right? To their server. and that's the IP address. So we use the 0 connection ID here. And now if I go on, you can start seeing the same pattern. We're going to open a TCP connection, close it, HTTP, redirect to another page, right? And the same thing. We're opening to Google Analytics this time. So imagine the work that the client is doing by just having all these ads, right? So much work. So Google Analytics, and then we made a request, HTTP 11 to whatever this thing, flight funnel. Again, another funnel, right? Another IP address. We communicated so many addresses. Google Analytics. This is the follow-up to this, right? That explains why this has a unique TCP connection while this hasn't, because they just closed this one because they're not going to reuse it, right? This was a redirect, so we directed to HTTPS. Again, we're going to use Quick to do that, and we're going to use Google's implementation of Quick because we're going to googleanalytics.com. And then the same thing, we're redirecting from this one to this. So that's a brand new TCP connection. But hey, guess what? This one is HTTPS on port 443 on Bright Funnel, but those guys don't support HTTP 2 or 3. They support HTTP 1.1 on top of TLS. Okay, so that explains why it's HTTP 1.1. So it's still TCP. Yeah, it's TLS. So there we did the handshake, but we didn't use Quick. So it's not technically UDP. It's TCP. All right. So we're just going through this. Let's go one by one. Then Google Analytics again. So there's another request, right? So what tells me they use the same TCP connection, and that makes sense. But look at this. We again made the same mistake by reconnecting to the HTTP. So the browser could optimize this, I believe, by avoiding to do this. Hey, we just connected to this Google Analytics. Why are you attempting to do it again? This scheme is very, very critical. So that's why people tell you, hey, your index or HTML should all have HTTPS. Don't have this mixed mode. Mixed mode is bad because, first of all, because of performance. Second, because of security. You don't want to send unsecure requests at all through the wire because they can be man in the middle real hard. And then another Bright Funnel API, HTTPS through HTTP 1.1. And then look at this. Let's continue. Then we get to our Google Analytics, doubleclick.com. So that's also Google. They use the Google protocol here, and they collect some information. Again, nothing of substance here. Nginx.org, going to nginx.org, but we're just doing ads. Just request to get ads, right? So H3, not really to get ads, but get tracked. Let's correct that statement. So this is H3Q50. That's again quick, and then another request, which will be redirected as we saw 307. Go back to redirect. So there's a lot of redirection. This could be avoided. So you can tweak your index.html page to be much performance by just avoid all this redirection. If you know a site will redirect, don't put the original site. Put the destination, the final one, to avoid all this stupid redirection. So again, we're using quick, and then there's add role here again. So that is just a request to roundtrip.js file, again HTTP1, and then we're gonna do it through HTTPS, and then do it again through HTTP. It's just a bunch of them. 302. What is 302? I forgot. 302 HTTP code. What is that? So that is found. That means, hey, I found something. Go and redirect it to this. I believe it has the same meaning, if I'm not mistaken, right? Exactly. Go to this location. Just, hey, I found what you're looking for, but it's over here. All of these redirection have similar meanings if you think about it. All right, look at this. I'm going to skip over this, and this is one interesting part. Add d.addrole.mgr.consensus.org is a different IP address, but that puppy actually support HTTP2. So that's over TCP. So now, the moment you start seeing that, this better use the same TCP connection. Now, once we use HTTP. But look at all of the stuff. The ones that are HTTP 1.1, everyone has a different TCP connection. right? Because we had to send those in parallel, and since it's HTTP 1.1, we couldn't send them in parallel without actually establishing multiple TCP connections. And Chrome, and that's a fact, they use 6 TCP connection on HTTP 1.1 per host. So you cannot open more than 6 connections. So you have a limit all of a sudden. With HTTP 2, you have around 200 requests simultaneously, I think, the stream size. And that could be configured as well. So 44985, look at all this beautiful stuff. All right, so H2, and then look at this. This is also H2, but this, guess what? This is a different TCP connection. Why? Because it's a different domain. It's also a different IP address. So that's a different thing. So look at this. Why didn't we communicate in H2? Because that's the same domain. Look, no, this is d.adroll.com. This is a.adroll.com. God, Nginx, what are you doing, guys? I just literally took Nginx because it's doing so much stuff. Look at this. We're coming to Facebook. There you go. I'm gonna skip over this part because we just explained H2 and all that stuff. So I want to go to this. Connect.facebook.net. We're going to facebook.net now. So facebook.net, I want to pay attention to this. Facebook, we connected to Facebook through the HTTP unsecured protocol, and that obviously, since unsecured has to be HTTP 1.1, we don't support unsecured HTTP 2 or 3 for that matter, right? It's a bad idea. Protocol specification, what's not. Connect. I want you to just see a lot of requests for d.adroll on HTTP 2. All of them has the same TCP connection. That's a beautiful thing, right? Because we're multiplexing all of these requests. We send them at the same time. We can, because HTTP 2 and in the same TCP connection. This is different. This is a different TCP connection. Now, once you see 0, I need to understand what the semantic of 0, but I think it was a temporary connection that is closed. It was open and then closed. That's my understanding. Or the main TCP connection kind of thing. I'll need to contact with some of my contacts at Google to essentially explain that to me. But that's my understanding here. All right, so we have that. And then here, look at this. Look at this guy. Facebook, we made a video discussing Facebook moving completely to Quick. So here's a proof. Facebook, we're going to facebook.net. We're using Quick. And guess what? It's now a different version of Quick than the one we saw with Google. This is H329. This is the final. I don't know if it's the final. This is the latest Quick specification, as far as we know, from the Quick team and HTTP 3. So they're using the latest and greatest. They implemented their own version, but that is H3 nonetheless, right? So look at this stuff. They're using H3. So now we're going to Google, we're going to Facebook, and now just all of a sudden Facebook know that I have interest in Facebook. Why? All of a sudden Facebook knows now that I have interest in Nginx. And if I can now right-click and say cookies, I bet you that the cookies has also been sent, right? Somewhere here. Did I specify the cookies? Do you see the cookies, guys? I don't see them. There you go. The cookies. I don't know what that is. It says 0. Maybe they weren't sent. Oh, yeah. By the way, this is an incognito mode. That's why it didn't send. But if I had any cookies, it would have been sent with this. So, yeah, same IP address. Again, same TCP connection. Not really TCP because this is Quick, so it's UDP. It is a logical connection nevertheless, but sure. And HTTP 1.1, going another domain here. So same thing, new TCP connection. And oh, look at that. Apparently Yahoo knows that I have interest on Nginx now. Look at this beautiful stuff. All right. Oh, and guys, as you can see, bunch of stuff. The same thing. We're going to facebook.com. Use Quick. If we're going to other sites, if I support HTTP 2, we're going to communicate with HTTP 2. And this all depends on the ALPN, if it's in case of HTTP 1, HTTP 2, and the TCP and the TLS, we tell the server that, hey, if you support this protocol, I do support them. So pick the latest. So the server will support whatever it picks. So and that's why the client actually can connect in HTTP 2. HTTP 3, We cannot know that fact because guess what? We cannot connect in a TCP and then ask the question in TLS ALPM because Quick uses UDP, right? So we can't establish a TCP and then ask, do you support HTTP3? And then only if they say yes, we're going to have to close the connection and reconnect in UDP. That's just expensive, right? So Quick has other methods of determining HTTP3 using alternative services, whether in headers or the DNS SRV record. All right, guys, that's it for me today. Quick video describing the network fields. Let me know, guys, do you use the network tab in your diagnostics or not? Let me know in the comment section below. I'm going to see you in the next one. What should I discuss next? Let me know in the comment section below. I'm going to see you in the next one. You guys stay awesome. Goodbye.